Hello students, I am M.M.DESHPANDE, Assistant Professor in ENTC Department of PES'S Modern College of Engineering, Pune. Today we are going to start with types of switch mode power supply. In previous lecture you have already studied linear regulated power supply and switch mode power supply. So today we are going to start with the switch mode power supply types. The types of SMPS are three types. Yes, the boost converter, buck converter and buck boost converter. So basically the question is how the types of SMPS are categorized. Think for a while and tell me how the types of SMPS are categorized. Yes, the types of SMPS can be categorized based on the converter used in SMPS. So boost converter, buck converter and buck boost converter. Three types are there. First type is boost converter. The name itself suggests the output voltage is greater than the input voltage. Here the MOSFET is used as a switching element. The inductor is used, diode, capacitor is used. The capacitor is already in charged condition and the load is connected at the output side. And to drive this MOSFET, the square wave pulse is given at the gate terminal of this MOSFET. So here when the switch is on, when the MOSFET is on, when square wave pulse, high pulse is given at the gate terminal of this MOSFET. At the time the DC voltage applied at the input, so inductor starts in the storing its energy and current flows through the inductor and the switch. When the switch is off, when square wave goes low, at that time switch is off and the D1 is on, as inductor reverses its polarity when inductor releases its energy. At that time diode is on. So when the switch is on, at that time the capacitor is already charged. So whatever voltage across capacitor, that will appear across the load. And when switch is off, the voltage across inductor appears across the load. It means the output voltage is double than the input voltage. Here the waveforms is when the switch is off, at that time there is no current flows through the switch, but then maximum current flows through the diode. And when the switch is on, the maximum current flows through the switch and no current flows through the diode. The uses: it is required where the output voltage is greater than the input voltage. It is used to create step-up or boost converter. It is used in small supplies. It is used in voltage or RF power amplifiers. The advantages are: it can set up output voltage without transformer, higher efficiency due to single switch. The drawbacks are: high peak current flows through the switch, output voltage is highly sensitive to the changes in duty cycle, large inductance and capacitance are required. Next type of converter is buck converter. Here in case of buck converter, switching transistor is used. The transistor is used as a switching element. The diode connected in parallel, the inductor, capacitor and the output load is used. When the switch is on, first when the switch is on, at that time the diode is in reverse bias and inductor starts storing its energy and capacitor starts charging through the inductor. When the switch is off, inductor starts releasing its energy. At that time diode is forward bias and the capacitor starts discharging through the load. So the output voltage appears across the load is less than the input voltage when the switch is on At that time, the capacitor voltage across the capacitor appears across the load. When the switch is off, at that time, the capacitor discharges through load. So, the voltage across the inductor is appear across the load. Yes, when the switch is off. L1 opposed sudden change in current and supplies current by building voltage across it. Advantages of buck converter: higher efficiency, lighter and smaller than LRPS for some applications, less power dissipation. Since power dissipation is less, no sink is required. Output has lesser ripples, wide range of tolerance, input range tolerance. Next type is buck boost converter. In case of buck boost converter, voltage polarity at the output is opposite than the applied input. The output can be of higher or lower voltage than the input applied. It is also called as inverting regulator. The diagram of buck boost converter: here the MOSFET connected in series, the inductor connected in parallel, the diode is connected, capacitor is connected, and load is connected. Here you can observe the capacitor is connected in opposite polarities. So output voltage is having opposite polarity to the input voltage polarity. Yes, when the switching transistor is on, at that time the source is getting isolated from the load as the diode is open. Yes, the diode is open. The source is getting disconnected from the load. And capacitor tries to maintain the output voltage as capacitor is already charged. When the switch is off, the diode will get forward bias due to the inductor polarities. As the inductor releases its energy, it is having opposite polarity, and the capacitor again starts charging. So when the switch is in off condition, it will act as a boost converter. When the switch is in on condition, it will act as a buck converter. It provides inverted input. It will work as a both buck and boost simultaneously. It is having higher efficiency. Short circuit protection can be easily implemented. Buck boost converters are used in self-regulating power supplies. The features of SMPS are: isolation between source and load is possible, less losses, higher efficiency is there, high power density is there, control direction of power flow, multiple outputs are there, low harmonic content, small size of filter components, controlled power factor if source is AC, limitation for minimum output ripples, require minimum load, tight output regulation and faster dynamic response, generate EMI RF noise, needs shielding. It generates EMI and RF noise which needs shielding. Thank you. Hope you understand all the converters which are the types of SMPS. Yes, based on this you need to solve one quiz given in the link below this video, and after that please give your valuable feedback. If you are having any doubts in the contents of the PPT, you can approach me at meghna.deshpande@moderncoe.edu.in. Yes. Thank you, student. Thank you once again.